Okay. All right, well, if there's no... Yes?
One more question. 2.424.
Oh, yes. So, was that the one somebody was asking about?
No, it was 2.3.
2.3? Okay. Number 24 seems to be a common thread through sections giving us trouble. So 2.424? Ooh, yummy.
Find a partial that's fine.
All right, let's take a look at this. This will be a nice review of exact. What's the idea with exact differential equations?
Second derivative must be equal.
Function of exact, or when you take the derivative of them.
All right, so let's have to check if it's exact, right? If you get the cross derivatives equal each other, right? That's good old Clairaut's theorem. But what's the idea behind the solution to an exact?
They came from the same function.
Came from a single function equal to c. So that's the idea behind it, is there's f of xy equal to c. I took a total derivative of that, and that's where my dE came from. Right? And the check is related to that assumption. If our check works, then the assumption must be true. It must have come from some single f. So did this one just run into a snag at some point?
No, but like the question doesn't say check if it's exact or not. But what I did, I multiplied both sides by y to the power of 5, and then it's not going to be exact.
So let's see, we get 3y squared minus c squared y5 dy dt plus t over 2y to the fourth, okay, equals 0. Yeah, okay. So, I mean, one of the very first things you could do is to just multiply by dt, right? And I want you to realize something there. I don't know if I did this. I didn't really try not to be honest, but there's a whole idea of if you take it too far, it won't be exact anymore. So, what's up?
Yeah, so how to know that? Like,
Well, I would check it out the way it is first before I do anything to it. Right? Besides this, you have to do this. So you know what m is, you know what n is. Are you with me?
okay.
M and n don't really matter. They're just the two different coefficients for the d stuff, right? So this one I have to do what? D what? Dabba by dabba what?
M.
To check. How do I check? What do I do the derivative with respect to? What's it already been done with respect to? Y. So I got to do it with respect to t of this, right? And what do I get? I mean, this piece is all dependent on y. Who cares? So this piece
Negative 2t over 5 y.
over y to the fifth, and sure enough, what happens here? What's d by dy of 2t over 2y to the fourth? This is close, right?
Negative 2t to y, 5.
Yeah, because it's going to be exactly, isn't it? Because that's negative 4. So it'll be negative 4t over 2y to the fifth, and that's negative 2t. Yeah, there you go. But this is I can't remember now if I tried to avoid problems like this, because I really didn't want to get into the integrating factor for if it's not perfectly exact. Because if you did multiply everything by y to the fifth, as you discovered, it's not exact anymore. So there's a process to figure out what to multiply by, and if you did the process, you would have found 1 over y to the fifth, which would have said, don't do what you did in the first place. I really want you to understand, if I multiply everything by y to the fifth, is this going to still be exact? No, right? In fact, is everybody cool with the fact that this means it's exact? Is everybody cool with that?
Yeah.
Okay, so this is exact the way it is. Now, if I would have, unwittingly, right, because you're our unwitting participant in this experiment, if I multiply everything by, you multiply everything by y to the fifth? Okay. Ct over 2y. So if you check it, d by dt would be negative 2t. d by dy would be t over 2? Nope. Right? I guess. So it's a very precarious balance for it to be exact. It's really easy to take it off of that balance. There's a whole process to go through to figure out what you've got to multiply by to make it exact. And here I would have just had to multiply by 1 over y to the 5th to get it back to the way it was to start with.
What did you call that? An integrating factor?
Yes, we should be familiar with that phrase. Because what does the integrating factor normally relate to? True, that's what it is. What does it relate to? What DE?
Differential
What type of? True? Let's break it. Let's narrow it down a little bit. Linear. There you go. Linear DEs are the ones that require the use of integrating factors. I like it, if they're not separable. Right? But there is a whole thing in this section about integrating factors for exact. Things that look like they could be exact. Which is kind of disgusting, so I really don't want to go through that. I think I tried to pick homework problems where if you just don't mess with it too much, you'll be fine. Right? Does it make sense, though? Does it make sense that if you could easily knock it off of being exact? You just got to multiply or divide by something, and the whole thing, it doesn't work anymore.
Yeah, I understand that, but like they say, the exam says, check if it is exact or not. So do you have like to multiply by something?
Oh, no. In fact, if I gave you this and it said, tell me if this is exact or not, your answer would be no, it's not. I didn't say, tell me if it could be exact. That would be the evil question. Right? Tell me if this could be. And to be honest, you can make almost anything exact. It's just that the thing you got to multiply by very often is remarkably disgusting. So then you say, is there another form it's in? Because how many forms can a single DE be in? Many. We've already seen the linear could be separable. So you don't have to do an integrating factor if you notice it's separable. Right? But it could be 3, 4, 5 different forms, and you just pick the one that seems to be the best. So yeah, I would never ask, could this be exact? Because the answer is almost always yes. What do you do to make it exact? Normally disgusting things. If I just made a DE up out of nowhere, it could be exact if I multiply by this horrendous thing. So why would I want to do that? Yes?
So is there like a form for exact DEs for the integrating factor like there is?
Yes, there is. I mean, it's if you're curious, it's on page 69, middle of page 69, in blue. And not surprisingly, it looks a lot like e to the integral of something dx, like the integrating factor for a linear, but it's e to the integral of a mess of m and n business dx, yes. So you can always do that. Can you always integrate it? No, but you can always find that. So that's what I mean by almost anything can be exact. It's just that you don't want to deal with most of them. It must be a better form if it isn't already exact. Yeah. Is everybody cool with that? So I understand your concern. My question will never be, can you make it? No, it will be, here this is this exact? No. It failed to check. Cool? Okay. All right. Okay. Anything else from homework stuff? That was a good review. I like that. All right. So we're going to get into 2.5. Knock this bad boy out. Let's see. I don't know if I want to start with that one. That was kind of gross. We have a nice one. Let's see. Not really. All right.
Which title for 2.5?
Okay, here we go. Say again?
Title for 2.5.
So 2.5 is actually, the title is Solutions by Substitution. But the two substitutions that are in 2.5, there's one called, now this is where this gets evil. This is the one that I said earlier is the lesser used meaning, but for 2.5, we'll see what it means. In general, this means a DE that's equal to 0, but for section 2.5, for solution by substitution, this is going to mean something very, very, very specific. But if I'm in a DE course and somebody just says homogeneous or homogeneous, however you like to say it, that means a DE equal to 0. That's what that means, right? Not equal to some function of x equal to 0. For 2,5, it means something very specific, right? And you can go through the whole history of why they use this word twice in 2 different ways, but oh well. Normally that means there was a duel and it was a tie. They both killed each other or they both survived, and then they both were accepted. There were a lot of duels in the history of math. You guys don't even know. You should look up somebody named Cardano. Anyway, all right. And the other thing in this is going to be Bernoulli's. And good old Bernoulli got to get into this somehow, right? He does too much shit. Keeps our planes going and does a lot of stuff with fluids and stuff. He's got some DEs going on too. So those are the 2 types of DE that are in this section. They both are just based on substitution. They're like an advanced version of U sub. And not remarkably, we're going to use U's as the sub, but it's not exactly U sub. Okay, so let's do an example of homogeneous. The idea behind this is, let's see, yeah, why not? Sure, let's do this one. Where'd it go? I like it. Is this separable?
No.
No. Let's rewrite this a little bit. There's a few different ways to approach this, but I want to get to the idea very quickly. So let me rewrite this. Let me kind of cross multiply. Can you divide by something so that the main idea with homogeneous is it involves ratios of x to y or y to x? That's the main idea behind this. Can you divide by something to make that happen? Yes, you can. Well, like, give me something you could divide by. There's a couple different answers here. You can either divide by x or you can divide by y. So let's divide by x. I love it. Somebody's got some balls out there. So divide by, she says, no, not really. I'm like, well, you know what I mean. You know what I mean. So if I divide everything by x, so I get y over x plus 1 dy equals y over x minus 1 dx. That's amazing. Okay, now the idea behind this, if you can do that, if you can rewrite the dE so that the only variable parts are some ratio, that could be squared, that could be cubed, that could be sine of it, that could be square root of it, natural log of it, but it's got to be that ratio. And you can have both ratios at once, because one is just the other one to the -1 power. So it could be to all kinds of powers. Is everybody kind of with me? If you can do that, if you can make that ratio, those ratios show up, then you can do this method. And this method is definitely not always the best method to use. But here's the method. So now I can say let y equal ux. So the idea that we're using here, this is most closely related to u sub, because I would just let u equal y over x. Do you guys see the idea? If I let u equal y over x, I make the form I'm working with much easier. Right? But the problem is I can't have dx and dy. I got to replace my y, my dy, with a du. Same idea with 180. So it really is very closely related to u sub. You guys still with me? Some of you guys are like, you lost me the minute I came in the door. Shit. So what's dy? Let's see if you're careful here. What does u have to be? What kind of thing is u have to be? Because what is u really? What is u really? U is y over x. So what is u? Is it a constant?
Yes.
So you know that y is some multiple of x somehow? You know this magically? What could the function y be? Anything. So what's y divided by x? It is still a function of x. What if y is ln of x? What is y over x then? Ln of x over x is still a function of frickin' x. You guys see what I'm saying? So u is a function of x. So why am I making that big point? Because how do I do dy now? What do I have to use? Product rule, there it is. So I got u dx plus x du. So that's the next level. That's why it's not quite u sub, truly. It's got a mixture of things. So it's kind of like the next level u sub. Let me stop here for a second. Is everybody so far so good? You got, yeah, no? What's up?
So we chose y over x for u, and then
Yes, because it's the thing that's repeated, and if I choose u for this, it's going to make this much simpler. Because y over x is a function of x, is it not? Which is really the main idea of u sub. Just say this shit is a function of x. Let me call it u, make this piece look easier, as long as du is in there somewhere. That's the whole idea of 180 u sub, right? That's the whole idea. So here I'm like, let me u equal this. It's going to make this look a lot easier, and I can figure out what dy is, so that I have only u and x running around, which is exactly what you try to do in 180. Complete substitution for y into u. Okay, maybe. Now let's just explore what happens. Let's just explore what happens. I really just want you to get a feel for why it makes sense I would try this, that I would think it would lead somewhere. So what do I do now? Now I just substitute. It's amazing. That's why this title is Substitution, right? So this is u plus 1. What's dy? That mess there. So, ooh, I'm going to FOIL. Oh, shit. That sucks, but too bad. Equals u minus 1 dx.
Well, the x needs to be replaced too. Dx.
No, definitely not. I really want this to make sense because so in 180,
Because u is a function of x, therefore.
yeah. What would you do with this? You would, don't use trig sub, right? You would let u be x squared minus 2, right? And then du is 2x dx.
Yeah.
So this is your dx going into du, but now here we got dy and dx. I can choose which one. That's really why it could be this or this. So if I let it be x over y, then x would be v times, they very often use v. We can just always use u if you want to. Do you guys with me? But then it would be x equals uy, and then it would be kind of the other way around. I want to kill all my x shit. But here we chose this, because somebody told me divide by x, so we chose this. I really want that. So we chose to get rid of my y shit and replace it with u and x shit. See, that's exactly what this statement says, isn't it? Get rid of y shit, replace it with u and x shit. So I want to get rid of my dy, replace it with u and dx and du stuff, right? Now I just got to, can you guys do the next step? Simplify that thing out.
Of course.
Some stuff's going to cancel, thankfully, a little bit. And you'll see something really, 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 really nice happen, which will then explain why we do this at all. Okay. Is that cool? Did I mess up anywhere? I'm a fellow human. I can mess up. I think I did that all right. So what cancels? Yeah, the u dx. And let's see what we got here. We got u squared dx plus ux du plus x du equals negative dx. Now what should feel kind of natural to do here?
Factor out the u.
Say again?
No, factor
No. Yes, all right, so what's always going to happen? What is always going to happen for this method we're using is once you do this, you will get a separable equation. And what is the nicest DE you could hope for? Separable most of the time. Right, I could throw some shit in there that makes it impossible, so not all the time, but most of the time separable is the holy grail. And when you notice it might be separable, that immediately tells you to get all your dx stuff on one side, all your du stuff on the other side. And then try to get your u's and x's to match up too. So if I move, let's see, I'm just going to have to suck the bullet here and just accept that there's going to be a bunch of negative shit somewhere, so I'm just going to put the negative shit over here. I don't know if suck the bullet was the right thing to say there, but I'm going to stick with it. Now this is what mystified some of you guys a little bit, but you can see why it's separable? Is everybody cool with this is separable? Because there's x stuff mixed with my du stuff, but I can just freaking factor that shit out. And then over here, and in fact I can make this even better. And over here I can take out Now, to be completely honest, I don't know if you guys noticed this, but it might, well, it doesn't really matter to me. I'm just going to let that fly. And now it's very obviously separable, right? So now I get u plus 1 over negative u squared plus 1 du equals dx over x. Now, some of you guys, I'm a little worried about if you're, sometimes when you get to a higher level course, you sort of focus so much on the new shit that your old shit starts to kind of lag. But we're having some trouble making sure that things get to other sides of equations for the right reason. They don't just sort of, you know, like transport themselves or instantaneous transmit. They have to actually subtract or add to the other side. I think for some of us, they're just sort of popping up on the other side because we want them over there. So hopefully, obviously, you've got to be careful about doing that because then any integration you do out there is shit. It's not going to come out right. So somebody help me out. Who's got a plan on where to go next? I can pretty much just integrate. Now this kind of sucks a bit, right?
But the X is nice.
Yeah.
That was a right.
See now? She's already done half of the problem for us.
No problem, guys.
So now we just got to worry about this yummy thing. Who remembers what the integral of 1 over u squared plus 1?
Inverse method.
Okay, cool. And you see how you can just pull this apart. So the u over this is just a m sub now, right? It's already u's. You can't do u sub. You guys okay with what's happening? I'm going to pull this negative on that side just to get it the hell out of the way. Is that cool? This side's already involved enough without the negative. That's what I was going to say earlier, is when there's a lot of shit with one variable, just take the negative to the other side. So you don't have to worry about it with all the other stuff you got to worry about. Somebody, and then so now I can just break this up. Now this is going to be, now this is where you guys got to be careful. It's natural log because the derivative of the inside is up there except for a factor of 2. This one is not natural log though, my God, because its derivative is not there, but somebody just told us arctangent of u. So if you did trig sub on this, you'd get there. Oh man, I was trying to save us some ugliness for the first example problem, but I sort of didn't. Now what is u? Remember what u was? The answer can't have u's in it.
That's y over x.
Y over x, 11. So this will be 1/2 natural log of y over x squared plus 1 plus inverse tangent of y over x equals negative natural log of x C1.
So, would you go?
Now there are a couple things you could do.
Sorry, since you see like this is denominator, make it easier, just break it
Not a lot.
to two.
You could do something. Do you see how this would be y squared plus x squared over x squared?
This is just our number.
LCD? And then it would be minus 1/2 natural log of x squared, which is minus natural log of x. The natural log of x's would cancel.
Just know you're making sure you're
No?
going to use it.
All right, let me stop. All right, let me make sure. Is everybody at least semi-decent with what's happened so far? Separation of variables is nice because it takes you back to the hardest it could be is 180.
Yes.
And I know 180 can get kind of gross, but it just depends on what's in here, right? The hardest it could be is 180 with separation of variables, right? And it's pretty soon you'll be like, that's fine. So everything here hopefully is nice. I can break these up because that's not easy to do. That's one you could either know or you do strict sub to get it. Right? Now it's all about the part that a lot of us kind of die on a little bit is how to simplify this a bit. Yes?
Is it totally necessary to have the one on the C? When
Yes.
we know whether or not split?
Yeah, I can't remember, when did I do that? I had a C and then I brought the negative over. I should have called it C1 to begin with, to be honest. And if I left the negative over there, I would have just called it C1. And then if I do something else, I'm going to call it C2.
So does the
Every
left,
operation is a.
Every time you attack the C and suck whatever it is in, if you double it, it's not C1 anymore. Right? Yes?
should the left have a C as
No, the minute I wrote this, I sucked this guy's resultant C over. I mean, that's kind of like
Okay.
inherent. You just worry about one side with a plus
Okay.
C.
Math magic rules.
C on the left side.
It's an acceptable thing to do because it's always going to happen.
Just on the-
If you said plus C1 and plus C2 and then you subtract C2 and now you got C3, when is it going to happen? Every frickin' time. So
No,
why?
and C1 could be right on the other side as well, and then just not on the X side.
Oh, sure, of course. You can
Just
either
look
side.
at it.
Why did I write it there? Because that's the side that we did. But it doesn't matter what side. Yeah. Okay. I like it. I like it. All right. Now watch. The one thing I would say we should at least do here. I never have time in this class. It drives me crazy. Is everybody cool with this? LCD between these two, so it's y squared plus x squared. Make sure that's x squared. Oops. Yeah. Yeah, that's right. Okay. Plus inverse tangent equals. Now watch. Is that cool? LCD? Right? Okay. Okay. So isn't this 1/2 natural log of y squared plus x squared minus 1/2 natural log of x squared? Right? And then, of course, this is just natural log of absolute value of x, and then those cancel. That cancels with this. That's what I'm trying to say. Right? Now, on a test, if you didn't do that, I'm not going to take 1 billion points off.
You still take on points.
500 million. Let's see if there's anything else worth doing to this thing. With that inverse tangent in there, it's like, what the shit could you do with this, really? So, I'd say that's a pretty good place to stop right there. I don't see any good reason to do any more to it, to be honest. I'm always open to suggestions. And you guys are like, I would not have done that much to it. But you have to start being able to kind of determine, is there something I could do, or, is it not worth it? And the answer is not always, it's not worth it.
is it supposed to be
How do
minus
you
or
drop
plus?
the x squared in the denominator?
No, I broke it up. Pop.
Oh, okay.
Right, the natural log of the division is the difference of the ln's. Yeah. And the 2 can come down, so it's the same as that. Yeah, I like it. Oh, you look so excited about that. All right. You'll get, if not all the points, you'll get most of the points for getting here. And for this problem, if you didn't go that next step, I'd still give you all the points for this step here. I mean, it's not the most immediately obvious thing, and you got other problems to worry about on the test. I understand that. It's only if there's something that should be really obvious that you can do, and you don't do it, you're going to lose a point or something.
Right, there's no arc 10, right? You just do ln e to both sides, that'll be.
Yeah, if this wasn't here, I'd
Yeah,
try to
it'll
do a
be
few more
easier.
things, yeah.
Mhm.
Yeah, but with that there's really no reason. No reason. Okay, okay. Considering my other example was semi-gross. That's not too bad, to be honest. It's nowhere near as bad as this one. Here, let me let you guys try this one here.
Just give us
Everybody got that? I'm recording it too. Yes?
How do where does the negative 1/2 go? From the OS?
Here?
Yeah, where does that
It's here.
go? Okay.
So if I rewrite this, it's going to have a 1/2 in front. And why is it minus? Because it was on the bottom.
Oh.
Yeah,
square
the
to 1/2.
log of the quotient is the difference of the logs.
Okay, I see.
Oh man,
Yeah.
free
Yeah.
calculus. Coming to
Darn
kick
you,
you in the
algebra.
nads.
So my calc teacher made us a shirt say "Darn you, algebra." It's not the calculus part. It's algebra.
Was it my algebra students came up with a new thing for PEMDAS?
Mhm.
They did, not me. Just so you know, it was they said, please excuse my deficient algebra skills. Right? And I'm thinking that goes through farther than you guys
So it's
realize.
DUA, D-U-A, DUA.
Huh?
So darn you, algebra.
Oh,
darn you,
DUA. All right. Do a dabba. No, I'm not. Nobody picked up on that. Good. So let's go on. Let me let you guys try this one. This one is not quite as gross at the end as that one was, but is a little bit. Let's start you off in a nicer place.
Still homogeneous?
Yes. So I'm telling you off the bat it is homogeneous. Now I want you to realize there's always a choice, and the choice leads to easier or harder integrals. Can you always tell which one is going to happen? Not always. But the choice is, do I divide by x or do I divide by y? Or some power of x and power of y. Do I make y over x's or do I make x over y's? And that's a choice. And it'll work either way. It's just sometimes one way will be easier than the other. Sometimes you can tell which way will be easier and sometimes you can't. It's very much like life. Holy shit. So try a way. Let me just see if it naturally happens both ways. Try to attack this the way we just did the other one. I have a feeling most of you guys will divide by x just because that's what we just did. You could divide by y also, and it will still work.
Seems like easier to do one.
Maybe.
Maybe, who knows?
I don't know. I did it a way. I didn't do it the other way, so we'll see. I don't know what they did. Yeah, yeah. Just so you know, the book stopped at the same place we did on that last problem. Doesn't mean either one of us is right or wrong. Right? Yeah. All right, let me try to catch up to you a little bit. Make sure we're all going down the right path. But since there's two paths we could have taken, what did somebody do? What did you guys?
Divided by y.
Divided by y? That's the first thing I heard. Some of you guys are like, no, it's too bad. So if I divide by y, one little thing you have to realize, hopefully this wasn't a big deal, is right here. Of course, right?
It's going to be root of x over root of y.
Multiply root of x over root of x.
No.
Root of x over root of y.
Okay, yeah, right? Why? Because this is rad y squared. A y cancels, you get rad x over rad y, which is big ass rad over xy, x over y. Okay. And there's that ratio I want. I don't want anything in the way of that ratio. I've got to be able to make that ratio on its own. It could be inside something, raised to a power, but it's got to be together. So since I did this, that means I'm assuming I'm going to let what be what?
X over y.
Yeah, x over y is equal to u. You'll see the book says v. You'll see my handout says v. Doesn't matter what the shit you call it, right? So x equals uy. So then, notice this. Why is this now? Can you guys see why this was the better way to do this? A little bit better? Because if I would have chosen the other way, I would have definitely had to FOIL, and FOILing creates all these other terms. Although very often there's terms that cancel. But it does seem better to pick the way that you're not going to have to do that. Is it always a better way? No. That's what I mean. You can't tell at a time. If you reach a snag and you're like, I don't know what to do, go back and try the other way. That's a part of the process. So what do we get here? We get, we got to do this. dx equals u dy plus y du. So now I've got negative u dy minus y du. Is that cool? If you did it the other way, just kind of hang out. Plus, let me break this out. Is that cool? This is going to be u dy plus u to the 1/2 dy. Almost always, no matter what you do, something's going to cancel. You don't have to make noises. So then I get, this is cool, do that, divide by y, I get dy over y equals, divide by that, I get u to the negative 1/2 du. Is that very cool with that? I mean, it's separable. I know if I did this correctly, if I'm doing this homogeneous idea, it must be separable. That's one way to know you did this wrong and this wrong, is if it ends up not being separable. You did something wrong. Did I do that right? Looks like it's all right. dy over y, du, but that's in front. Like, and I just attacked with the intervals, and this is a lot better, right? Than the last problem. I should have started with this one. I'll let you guys finish that out. Good. Even if you're not sure what to do, just try something. But what I always joke about is at least draw a duck or something so it looks like you're trying something. You're not just sitting there staring at me like, finish it. Where are we at? Sorry? Oh, because I'm going to have to divide by this. Which I just wrote like this because then it's just power.
We can't do it over y to the side.
Yeah, you can move y. So you move that over here, right? Right? But then you have to divide this to get it with the u's. You have to divide this to get it with the y's.
Okay.
Yeah. Yes, yeah, you just apply algebra and let what happens happen. Don't let the part of your brain that goes, it would be so much easier if only, too bad part of my brain. Apply the algebra, let what happens happen. I think that's part of what happens. We go, there's got to be a way to make this look better. No. So then I get L half 2 by y. Careful now.
U to the 1/2.
Yeah.
Oh, negative.
2.
Yeah. So it'll be 2u to the 1/2
Plus C.
plus c.
E both sides.
We'll say c1 just to be careful. And really, there's a couple things to do. What have I not done yet that I need to
Plug
do?
it back in.
Yeah, natural log of y equals 2
X over Y.
x over y 1/2 plus c1. There's really not a lot you could do here. I mean, you could do e to both sides, but you really haven't solved for y, right? What else could we do? Not much. I
Maybe you
mean,
could find C1 as well.
you could do this. You could subtract c1 over, so that's plus c2. I mean, just to show you, if you said this, I would be okay with it, because there's really no point. But a little bit you could do is and this, and then square, let's see, square both sides. Oh, that's gross. And then you can multiply by y. So at least you got it solved for x in a way. You see that? Divide by 4, you never want to, but at least it's solved for x for the most part, right? But again, like I said, if you stop there, I'm semi-okay with that. I'm okay with it enough to where I'm not going to take points off.
And again, it doesn't matter which side the C is on?
No,
Okay.
no, it doesn't. But yeah, I mean, you see how you have to follow it, though.
Mm-hmm.
Yes?
What's the advantage of renaming a C2 when you move it over?
No advantage. You could just say minus C1.
Okay.
But it's kind of convention to leave it as plus, yeah. It really, if you make it minus C1, at least you're tracking that. You either track it by changing the constant's name, or you track it by affecting the original constant the way it's supposed to be. Don't just go, oh, I'm just going to put it over here as plus C1. No. It's got to be one of those two things happen. I like it. Yes?
It's constant, so it can be on either side.
Yes, but you got to, once you pick a side, you got to track the motions.
Because once you plug in points, you affect your math. 'cause
Yes.
they're plus and negative.
How do we know when to stop for the first one? We just set it equal to the constant, but for this one it looks like.
Well, I just wanted to show you what you could do. You actually could get x by itself because it is unentangleable. What's a good word there? You can unentangle it. That's a word, right? Disentangle? Yes.
Detangle.
Detangle? Sure. I don't know. For some reason, I got that stupid tangled movie in my head now. You could get x by itself. You could. If you didn't see it, I'm not going to kill you because of that. You with me? But just to show you, you got to get used to seeing how you can get something like that by itself. It's
So
kind of important, yes.
you want us to just keep doing it until, like, if it was x plus y right there, we'd stop there. Like, it would be no more.
You mean like up here it said x plus
You
y?
couldn't separate it.
Yeah.
Or it's just something
Again, like I said, I wouldn't take points off if you stopped here. It'd have to be something a little more obvious than this for me to take points off.
Yeah, like something easy.
Yeah, like if I had negative 1 over y equals 4x plus c, okay, you could solve that for y, right? Or x for that matter. You with me?
Yeah.
So yeah, if you just stop there, I'm like, no, that's not good. Yes?
Would it be wrong if I eat it like at the top before the box answer? Like,
Eat it.
Yeah, eat it.
That's my
Like,
term.
If you leave the u in there,
yeah. Or,
well then, that's no good. Because my question didn't have any u's. How can you
no, I
answer
mean,
any
like
u's?
if I eat both sides and then I substitute it for you,
Oh, thank you. God. I'm like trying to figure out.
and then
Eat it, like mathematically hit your face on the concrete. No, you mean eat.
Yeah, like
eat it.
eat it.
No, remember earlier, eating it would be like trying to solve for y, but there's a y up here too, so that's not really making it any better.
Messier.
The only variable you can really solve for is x, because that's the one you can get out of being tangled up with y.
That's a
Don't take me
different
down that road again. Okay, we got a whole other substitution method to talk about. Bernoulli. Got to give him his props. Well, there's brothers. There are a few Bernoullis running around. Jacob Bernoulli and I think it was Bart. No, Jacob and somebody else. I can't remember the other Bernoulli. I could totally be talking shit. I have no idea.
So, is there like a test to see if it's homogeneous, or do you just
There's
kinda
no
look
test.
at it and be like,
You
yeah,
just have to kind of notice.
Uh-huh.
There could be a DE that's only Bernoulli's. It's kind of hard to, well, it's not hard to develop it, but there could be. Normally that would mean it's really going to look gross, but Bernoulli's is sort of a last resort sometimes.
Okay.
Sort of, unless it's like so obvious that you just divide by x and everything. Okay, I'm going to do that. Right? There's no test though, unfortunately, not like exact. Okay. So here's the idea with Bernoulli. So if we have this, I'm trying to remember the form it was in for us.
dy dx equals p of xy, or plus p of xy equals f of xy to the n. That's what it says in the book.
What's up? Oh, I know. I'm
Okay.
going to start with what we know, and then build up to what they're talking about. Right, this is like the standard kind of DE, and then you got the next step, which is a little more standard to be honest, but I like to start here. You divide by A1 and you get this stuff here. I think this is where the book calls this. Did they finally call it Q, or here they're just calling it F, sure, whatever. All right, now, so this would be what form?
Standard form.
I mean, be more specific. Linear,
Linear, yeah.
right? It could possibly be separable also. It kind of depends, but it could be separable. Now here's Bernoulli's. Here's what Bernoulli's does. Bernoulli's has something right here. With n, what was it? Not equal to 1. Which kind of makes sense. If n was 1, I could just suck it into this. So, there's a really nice substitution you can make to take care of this. And after you do the substitution, it's going to become linear. And it kind of, yes.
Black is for Bernoulli's.
Yes. So this little piece adds in Bernoulli's. It adds in the problem that Bernoulli kind of took care of. The reason I like to do this, to kind of put linear down and then throw that in there, is because once you do the substitution, it becomes linear. It's almost linear, except for the stupid... So what you do is you let u equal y to the 1 minus n. Let me see if memory serves me. Yes, sorry. And then what I normally do is, help me out here. If u is y to the 1 minus n, y is u to the
Plus 1, right?
All right, let's try a specific problem. Let's try a specific problem and see what happens. You'll see why I like to turn it around, because then I can figure out what dy dx is so I can substitute easily. Because again, this is the idea behind this, is replace y with u stuff. So I got dy dx, I got to replace it with something du dx, right? Okay, so let's try a problem. Let's see. Let's try one that's not too evil. I don't know. Let's try this one. We'll see if that's not too evil. But everybody get the basic idea here? And again, a lot of math is like this. I know how to do this. What if there's this extra little shit? Oh, okay, how can I take care of that extra little shit? Okay, here's a process that worked. Oh, yeah, okay. So a lot of that is kind of like, it's related to something called Perturbation Theory, where you start with some known thing and you add some extra little shit. And you go, okay, all right.
Wouldn't that be square root of u and 1 minus the exponent?
So for example, if u equals y to the third, what's y equal to? U to the 1/3, yeah.
Yeah. So
If u equals y to the negative 2, what's y equal to?
u to the 1/2.
U to the negative 1/2?
Something like that.
Okay. That was kind of pushing it with all the n stuff. You guys got this here? And remember, this is all on that page I gave you. This one's at the very bottom. It tells you the basic idea how to get it started. Right? Okay. So here's this problem. Let's do this problem together. Just because we're running out of time as always.
So when you have u, y equals 1 minus n, in order to solve y, you have to y used to 1 over 1 minus n.
All right, so this is perfect. What's p of x currently?
-1.
-1. I like it. What's f of x?
This e to the x.
E to the x. I love it. Okay. So, for example, if f of x was 1, how would I attack this problem?
You use,
Separable.
yeah. So
Yeah, all right. If that function is actually just a constant, not really truly explicitly dependent on x, it's going to be separable. Right, as long as this one's also not. So that's why sometimes a linear could be separable if those coefficients work with us. Okay, but this is definitely not linear. It's not separable. You guys see that? All right, I like it. So this has got to be Bernoulli's because it's not linear because of this stupid thing, but that means n is what? N is what? 2. So I want to let u equal y to the
n minus 1 minus
1 minus n. So I want to let u equal y to the -1. Now in this case, this is nice. This means that y equals u to the -1. Yeah. All right. 1 is the flip of the other one. So how do you rewrite that? Okay, 1 is the flip of the other one. There you go. You guys with me? So let me know when I lose you. What's going on?
How is it still -1? I just don't
U to the 1.
Yeah, what do you do to both sides to kill that -1? You raise it to the -1 power, right? -1 times -1 is 1. 1 times -1 is -1.
Oh,
I like it. This is really just saying if u is 1 over y, y is 1 over u.